And we have talked about interference and standing waves. Let me talk about standing waves more, but in an organ pipe this time. So, standing waves in an organ pipe. Okay. What do you mean by an organ pipe? An organ pipe is just a cylindrical column with air inside it, or maybe some medium inside it. Okay. So this is just a cylindrical column with air inside it. I'm writing air, but it can be any medium. Okay. Anyways, so this organ pipes comes in two categories, and we will try to study the standing wave formation in both of them. Okay. So one of the thing is closed organ pipe, and one of them is called open organ pipe. Okay. What do you mean by a closed organ pipe? So whenever I say closed, it means that one of the ends is closed. So you have a cylindrical structure like this, a cylindrical structure like this, and one of the ends will be closed and one end will be open. One end open, one end closed is called closed organ pipe. Okay? What about an open organ pipe? You have both of the ends to be open. Both of the ends to be open. So closed at one end, open at one end, and this is open at both ends. Okay? We'll try to understand what happens to a sound wave which enters in this kind of medium or in this kind of structure. Okay? So have you written till here? Can I start with the discussion? Great. So let's say formation of standing waves in closed organ pipe. Okay. So let's say I have a closed organ pipe like this. Something like this. And I put a source of sound in front of this open end. Okay? I put a source of sound S, from which comes out sound waves. Yes? And there are so many particles in this medium, na? Air particles. What is the job of a wave? What does it do in a medium? Yes, it disturbs the medium, right? It disturbs the medium, and let's say I have a particle which is here, this particle and this particle, which is at this end. So this particle will get disturbed, performs SHM if it were to be in harmonic wave. And what do you think? Yeah, SHM का direction कैसा होगा? ऐसा? Should it be like this? It should be something like this. Now let me ask you this question. There are two particles, one particle at the open end, one particle at the closed end. This particle, what do you think? Does it have space to move around? What about this particle which is at the closed end? Does it have space to move around? No, right? It won't move at all, or maybe it will perform very small SHM, but then this can move freely, this can't. So if I make this graph or the plot, I'm going to make y versus x का plot, then how should the y versus x का plot look like? If this particle has a freedom to gain maximum amplitude here, then what should form here? What should form here? Antinode, displacement antinode to be more precise. So I will have a displacement antinode here. What about here? Does it have room to move around? No. What will form there? Displacement node. So there will be a displacement node here. dn is displacement node. So let me make the wave. The wave should follow this. It should respect these conditions. And the wave should be something like this. Should be an antinode here, and then it forms a node there. When a wave hits a solid surface, it gets reflected back. Na? If you remember, I have talked about this in towards the end of wave motion, transmission and reflection. It gets reflected back with what phase reversal? Pi radians. It gets reflected by pi radians, so I think it should get reflected back like this. Yes or no? This is my incident wave, this is my reflected wave. So when a wave hits, when the sound wave hits the closed end, there is a reflection with a phase reversal of pi radians. Does it make sense? There is a phase reversal of pi radians. That's why the other wave should look like this. Let's say, let me give you some values. So let's call the length of the cylinder to be L and the radius of the cylinder to be R. Then what is this length? Lambda by 4. Does it look like that? I have one wave, this is lambda by 2, and I think this is what I have drawn. Na? This is what I have drawn. So that will be lambda by 4, and lambda by 4 is equal to what? So lambda by 4 is equal to L. This is one possible wave. Let me make some other possibilities, and you make them in new diagrams. Don't make the cluster like me. ऐसा कुछ. There's a possibility like this. Yes or no? What is the length of that wave? This is the wave that I have drawn. Lambda by 2. What is this length? Lambda by? This is lambda by 2. Lambda by 4. What is this length? This is also lambda by 4. What I am making here is this. See, I am making this. This is lambda by 2. What is this? Then what is the total length? 3 lambda by 4. So what is the condition then? The condition of this wave is 3 lambda by 4 should be equal to L. Please don't make this same thing in the same diagram. Otherwise पूरा खिचड़ी हो जाएगा. Try to make it in a different diagram, or maybe use color coding, different colors like me. Let's make one more, and then I will generalize. Let me make one more possible wave. This is another possible wave. Let me make it again so that it is clear to you. This is what I have made. What is the length of this one? Should be 5 lambda by 4, right? Because this whole thing is lambda, and there is a lambda by 4 again, so that will be 5 lambda by 4. What is the condition this time? Phi lambda by 4 is equal to L. I am just making all possible waves that can form in this cylindrical thing. Then can you generalize? What is the general result then for any nth harmonic? So the condition on wavelength should be equal to lambda n. So 2n plus 1 lambda n by 4, na? Yes? This is equal to lambda n is equal to 4l by 2n plus 1. What is the restriction on n? What is the restriction on n? Both of you sit away from each other. Should it start from 0? It should start from 0. And all the positive integers, huh? 0, 1, 2, and all those things. Acha, by the way, in some texts it's also written, acha, let me write it and then let me say. What will be the restriction on the frequency then? What are the possible frequencies? So V equal to F lambda. By the way, will the velocity of all these modes change? No, because velocity depends on bulk modulus divided by density of the medium, and density of medium doesn't change. On an average it will be the same for all of the modes, and bulk modulus doesn't change as well. So V is going to be same. V doesn't depend on n, doesn't depend on n or the number of mode. Then what is the frequency given to be? V equal to F lambda, then F equal to V by lambda. Don't just sit around, please write with me. बैठ के थिएटर नहीं देख रहे हो तुम लोग. कोई इधर देख रहा है, कोई खिड़की के बाहर देख रहा है. V is equal to F lambda, then F equal to V by lambda, then Fn will be V by lambda n. And what will this be? V by 2n plus 1 4 क्या नहीं ऊपर क्या आएगा 2n plus 1 into V divided by 4l. Where what is the restriction on E? N 0, 1, 2, 3 and so on. Yes? This is the frequency of nth harmonic. If you remember, I have done all of this discussion previously for a stretch string. So this is the frequency of nth harmonic. Acha, in some textbooks they also write it like this, or you can equally write it to be Fn to be Nv by 4l. But then can you guess what should be the restriction on n this time? What should be the restriction on n?
It can be 0, 1.
No, it can't be 0. Should be 1, 3, 5, 7, something like this, na? Should all be odd multiples. N should be 1, 3, 5, 7. Should be odd multiples. So in some textbooks they also write it like this, but then you have to remember it like that. So what is the first harmonic for both of them? Here n equal to 0 corresponds to first harmonic. Here n equal to 1 corresponds to first harmonic. What about the first overtone? N equal to 1 corresponds to first overtone. N equal to 3 corresponds to first overtone. Do you understand? Just keep on going in the numbers. When we do some problems, you will understand. Huh? Why odd numbers? What is this? What is it an even number? If you don't want it to be like this, then what is this? What is here? 1. There's a 3. There's a 5. All odd numbers. You do it and then you will understand. Is it okay with everyone? This is Fn. What will be the fundamental frequency of this mode? F1. So fundamental frequency, that will be V by 4L. And then I think you can see the formula that Fn can be written as NF1, where N के ऊपर restriction is 1, 3, 5. This is the frequency that you get. Yes? The frequency of the nth mode. Is it okay? Am I going too fast? It's all right with everyone? Great. So these are the frequencies. Just for fun, can you try to plot the delta P versus X graph, or rather P versus X graph? What do you think it should be? Go to class number 3 and ask for Parthiv's book. My notes. Okay? So let me plot it, P versus X graph. One end is closed and one end is open. You have a source here. Now tell me, you have pressure. What is the pressure in this region? That's P naught, right? That's atmospheric pressure. Everywhere there is atmospheric pressure. If you just look at a particle which is sitting at the boundary here, what do you think it will, or maybe some kind of little volume you can imagine, little volume, what will the pressure be there? Here it is P naught. By continuity, what do you think the pressure should be here? See, let's assume that the pressure is a little more than P naught. If the pressure is a little more than P naught, then what will happen? Then air will rush outside, such that the pressure gets equilibriate. Yes or no? If your pressure is a little more than P naught. If your pressure is a little less than P naught, then the air will come inside, such that it will become in equilibrium on this boundary only, please understand. Yes or no? So what should be the pressure there? By continuity reasons, it should be P naught. So then what should form here? Batao. In terms of pressure, what should form here on this open end? A node or an antinode? What is the pressure variation here? 0. So what should form? Antinode. Should be node, na? When pressure variation is 0, what should form there? A node. So it should be like this. This is pressure node. Yes or no? When you have a closed end, let's say that wall, and there are so many particles which are bombarding there, what do you think will happen there? Pressure will increase, keep on increasing. So what should form here then? There should be a pressure antinode. And now if you remember, even if we can't imagine this, we can actually just follow the statement that I have already given you last time, that a displacement node corresponds to a pressure antinode, and a displacement antinode corresponds to a pressure node. So if you remember, I used to make a displacement node here and a displacement antinode here. It should be exactly opposite of that. Yes. How should my graphs be like then? My graphs will be something like this, hopefully. Exact opposite of before. Yes? Yes. Exact opposite of before, and the other plots will be something like this. This is my P versus X graph. It's exactly opposite. Do you get it? for those who are trying to understand? बताओ, is it okay till here? Is there any problem till the अभी तक का discussions? It's all okay? I think everything is very intuitive. So I'm done with the discussion of closed at one end, open at one end. Now I will do the discussion of open at both ends rather. So is it okay? Done? लिखो जल्दी जल्दी, ये लास्ट का ही लिखना है ना बस. स्टैंडिंग वेव फॉर्मेशन फॉर ओपन ऑर्गन पाइप. Open organ pipe. Now what happens? Now look at this. Key. I have a cylindrical element like this again, some kind of pipe. I have a source S again. This will give off disturbances, and what will form here in terms of y versus x plot? Y versus x plot में what should form here? बताओ, what should form here? Displacement antinode? Antinode ना? And since it is open again, so it will be again displacement antinode. And if I want, I can make it to be pressure node and pressure node again, but anyways, let me make the plot. तो ये plot कैसा दिखेगा? You will have, अच्छा, now let me ask you this. Beforehand, we had a situation where one of the ends was closed. And then we used to say when you have one of the wave which is hitting the closed end, it gets reflected and comes back like this with a phase reversal. I have the other end to be open now. What do you think will happen? It just passes through. Is there any reflection? What do you think? Will there be a reflection? It doesn't depend on any of them. It will not reflect. This is the general answer, right?
Sir, maybe when it these boundaries it means.
Let's see. So when I have to, just based on this situation, I think I will have a plot like this. This is the wave which goes there. Now what happens? अब ये अच्छा मेरा क्या है, डिस्प्लेसमेंट एंटी नोड बोथ साइड्स. हाँ, अरे मुझे P वर्सेस X का ग्राफ बनाता हूँ, दैट्स मच मोर ईजियर टू अंडरस्टैंड. सो इफ आई मेक P वर्सेस X ग्राफ, देन देयर विल बी अ प्रेशर नोड एंड अ प्रेशर नोड. ठीक है, प्रेशर नोड का मतलब है कि प्लॉट ऐसा कुछ आएगा. यस और नो? लेट्स थिंक इन टर्म्स ऑफ एक्चुअल साउंड वेव्स. व्हाट विल हैपन? In terms of actual sound waves, when I have a pressure node, that means pressure उधर zero नहीं है, pressure variation zero है. So how will, so I think pressure is least. Then in terms of sound waves, what can you say? What will form there? Rare refraction or compression? Rare refraction forms since the pressure is low. So I will have a wave like this, and in middle compression, at the other end फिर से rare refraction. Rare refraction का what do you mean by rare refraction? That the pressure is less. Yes or no? Pressure is actually less. Then what will happen? The outside air rushes inside. The outside air rushes inside and it creates the pressure to be more. When it creates the pressure to be more, then this rare refraction gets transformed into compression. तो ये क्या बन जाएगा फिर? कंप्रेशन बन जाएगा. एंड इन मिडल ये रेयर रिफ्रैक्शन बन जाएगा. शुड आई रिपीट वंस? See, what happens is when your ray refraction goes and hits the open end, its pressure is less than the atmospheric pressure, and that's why air rushes inside. When air rushes inside, then your pressure actually increases. When it increases, then your ray refraction converts to a compression. Then when a ray refraction becomes a compression, then what is the phase reversal equal to? What is the phase reversal equal to? Should be pi again. So देखो, the actual plot is something like this. If you are finding it a little difficult, the actual plot ऐसा आएगा. हाँ नहीं होएगा, बता रहा हूँ. ये देखो, ये actual plot है where I have made the nodes a little outside, and I will tell you about it when I talk about end correction, but the nodes are little outside, and this is what happens. ठीक है. But anyways, when a compression hits the open surface, becomes a ray refraction. When a ray refraction hits the open surface, becomes a compression. So every time you hit an open surface, there is a phase reversal of pi radians. That's basically as if you have come back with this. So even when a sound wave hits the open surface, a standing wave will be formed. So a ray refraction hits the open end and gets converted to a compression. That means a phase reversal of pi radians. Does it make sense to you? A phase reversal of pi radians occurs, and vice versa. Yes? This is what happens. So even when you have open at both ends, still a stationary wave is formed. And what are the other possible waves? So let me make the other possible waves as well. I am still making P versus X graph. ऐसा कुछ तो. अच्छा, what is the condition here for this one? What is the condition? ये length L है. हाँ, lambda by 2 equal to L. What about the other one? Lambda equal to L can be written as 2 lambda by 2L should be equal to L. If I make a third diagram, what is this equal to?
3 lambda by 2 equal to.
So can you see a general pattern? What is the general pattern? N lambda by 2 should be equal to L. Does it make sense? So I am waiting you make all of this diagram, and please make properly, and then I will go on. अच्छे से सारे डायग्राम अलग अलग बनाओ, एक में कचरा मत करो. अलग अलग बना दो. देखो मैं डायग्राम वापस अलग से बना देता हूँ. One of them will be like this. One of them will be like this, and एक ऐसा. ठीक है. यहाँ पे lambda by 2 इक्वल टू L, यहाँ पे lambda इक्वल टू L, यहाँ पे 2 lambda by 2 इक्वल टू L, यहाँ पे. ठीक है. So please make the diagrams अच्छे से, separately, cleanly. Once you are done, then tell me. Written. So let me write the conditions. कंडीशन क्या है बताओ? What is the condition on n? N lambda by 2 is equal to L, or wavelength of the nth mode is 2L by n, and n can start from 1, 2, 3 na? If you remember, it's exactly the same result that we found for stretched string. What is the frequency के ऊपर? That's v by lambda n, and that's nv by 2L this time. You remember previously we found nv by 4L, और उसमें n odd था. यहाँ पे n can be any positive integer. तो थोड़ा be mindful, okay? What is the fundamental frequency here?
V by 2.
Not n equal to 1. V by 2. That means in general I can write Fn to be nf1 again, where my n again starts from 1, 2, 3. I'm just writing n again and again, but keep that in mind, okay? Otherwise पूरा कचरा हो जाएगा. If it is written, then let me write some questions, okay? अच्छा, बिफोर इवन दैट आई शुड राइट द लप्लास एंड करेक्शन, तो वो भी एक चीज़ होती है. नाउ द थिंग इज कि आई टोल्ड यू ना दैट एट दीज पॉइंट्स, लेट मी राइट द टॉपिक एंड करेक्शन. यस, you have a situation like this. Acha, by the way, I did not make the y versus x graph, but can you make the y versus x graph yourself? Instead of pressure nodes, there will be what? Displacement antinodes. So can you make the plots yourself? Can I leave that to you? Kar dena. So if I talk about pressure nodes, तो यहाँ पे एक pressure node बनेगा and pressure node बनेगा. But in actuality, it's not that. The thing is, I'm not going to prove it how it comes. This pressure node is actually shifted and it's come out. It comes out and it's actually here, a little away from here and here. And the length is given to be 0.6 r. And what is r? Radius of the cylinder. Then now you understand ki what should be the condition now. If I take this to be the length, then you remember I used to write v by 4L, v by 2L, but वो L नहीं होएगा, L के साथ ये additional correction. And if this is 0.6 r, this is 0.6 r, then what is the additional correction? 1.2 r. If you have a closed end, तो one of them is closed. Close के बाहर तो नहीं बनता है, close के अंदर ही बनेगा. So सिर्फ 0.6 r. So for open organ pipe, so for closed organ pipes with end correction, your Fn is given to be Nv by 4 L plus 0.6 r, है ना? Where n 1, 3, 5, all those things. और ओपन के लिए बोलो, ओपन के लिए बोलो कैसा होएगा? 4 नहीं होएगा, Nv by 2 होएगा, L plus 1.2 r. where n starts from 1 to 3 this time. So please be very mindful of what you are writing. Otherwise पूरा कचरा हो सकता है बहुत जल्दी. Does it make sense to you? So if nothing is mentioned in the question, then don't bother about end correction. If they specifically talk about it, then use it. Bolo.
So why is it shifted outside? Is it because the...
I am not going to answer that.
Why is it?
अरे यार बोलो बोलो क्या है.
Like, is it because the wave has to come out and then reflect inside?
The wave has to.
Come out of the cylinder just to reflect inside.
So अगर मैं ये प्लॉट बनाऊं जैसा मैं पहले बनाया था. है ना, और मैंने इतना ही दिखाया तुम लोग को, बट एक्चुअली ये है ना वेव, ऐसे जाएगा एंड देन इट गेट्स रिफ्लेक्टेड बैक
From what?
फ्रॉम द एटमॉस्फेरिक प्रेशर.
Why does it have to reflect this? It can also be reflected at the, at the boundary line itself. Why does it have to go out of that? Or
ठीक है, I'll tell you this next time. Okay. Remind me next time, I'll tell you that. Okay. So this is end corrections. Let's start with some problems then. जाओ जाओ. Attempt. I'm giving you 2-3 minutes and then I will start. बोलो क्या चीज़, क्या बोल रहे हो समझ. For this question, if I tell you everything, then I may as well explain it. Brainstorm थोड़ा सा, कोशिश करो.
7:8.
7:8 is correct.
7:8.
Yes. Should I start with the question? So let me do this one and then you attempt the next one. It's given that the third overtone, okay, not the third harmonic, third overtone of a closed organ pipe is in unison. So let me write for closed organ pipe. Can you remind me what was the harmonics formula? So Fn is equal to Nv by 4L, where N can start from 1, 3, 5, 7 and so on. Na? Yes or no? They are asking about the third overtone. This is the first overtone, not this 3. First overtone. What about this one? This is the second overtone. This is the third overtone. Na? N equal to 7. N equal to 7 corresponds to third overtone. So F7 is 7V by 4LC. L of closed. What about the open one? For open organ pipe, बताओ इसका क्या होएगा? What was the formula? NV by 2L. और इसकी क्या बात कर रहे हैं? फोर्थ हार्मोनिक. तो इधर कहाँ से n कहाँ से स्टार्ट होता है? इधर 1 से स्टार्ट होता है. तो फोर्थ हार्मोनिक कितना होएगा? n 4. तो what should be F4? That will be 4V by 2LO. And now I just have to equate the answer and I will get the answers. तो बताओ 7V by 4LC is equal to 4V by 2LO. और फिर LO by LC या LC by LO? I think LC by LO निकालना है. LC by LO कितना आ रहा है? Is it okay? This was very simple. You just have to understand what do you mean by third harmonic in each of the context. Can I write the next question? Tell me the answer. I'm giving you 3 minutes to think, then I will start. क्या चीज़? फ्रीक्वेंसी को क्या हुआ है?
Is it 300?
300 है, 300 है. This is 300 hertz. Okay. Attempt. One point? No, you are missing by a factor of 2.
0.55.
0.55 is correct. Give me for the other one.
So 0.82.
That's incorrect.
0.27.
Incorrect, both of you. Do the calculations calmly. You don't have to do it in a rush. Should I start? I will wait 2 more minutes, then I will start.
So 0.82.
Incorrect. Two point? Incorrect. Zero point 4, 1, 2 or 125. 0.4125 is correct. Okay then, and starting with the question. Urjo Kiriti. Rosa. So open organ pipe has a fundamental frequency of this. I think from this statement itself you can find the length. Open organ pipe ka fundamental frequency is equal to what? V by 2L is equal to 300 So that means LO is equal to V by 2 into 300 and this V is 330 ना. हाँ yes, ये गया 3 10s are 3 11s are 11 by 10 is 1.1 and divide by 2 0.5 है. Yes. The other thing is given, the first overtone of the closed pipe has the same frequency as first overtone of organ pipe, open pipe. First overtone of closed pipe कितना होएगा बताओ? N equal to what?
7V by 4L.
7V by 4L. 3V by 4L ना? And what about the first overtone of open pipe?
Sir, 2.
2V by 2LO ऐसा होएगा, है कि नहीं? Is it correct? Then this 2 गया, ये VV भी गया, तो LO कितना आया फिर? 4 by 3 नहीं, LC कितना आया? 3 by 4 LO. तो 3 by 4 से मल्टीप्लाई करो, आंसर आई थिंक आएगा 0.4125. Is it okay? It was fairly simple. ये कंडीशन बस लिखना आना चाहिए. फर्स्ट ओवरटोन का मीनिंग क्या होता है हर जगह पे. Everything else is very simple. Have you heard the term compressibility? Have you come across this term? Compressibility? सुना है ना, सुना तो लग रहा है ना. बस उतना काफ़ी है. लेट्स डू द क्वेश्चन देन. पढ़ा है ना पहले तुम लोग ने, पढ़ा है ना, बस फिर अब एक्सप्लेन क्या करना. रिवाइज करके आओ हर एक चीज़, तो फिर दिमाग में रहेगा. Yes. Attempt. I'm giving you 3 minutes, then I will start. Everyone knows what is compressibility? पता है या बताऊं? Uh-huh. It's just reciprocal of bulk modulus. Compressibility is 1 by bulk modulus. And compressibility talks about ki how much. So if bulk modulus is minus V dP by dV, then compressibility is minus 1 by V dV by dP. According to a change in pressure, how much will there be a change in volume? How much compress can you compress, how much can you not? है ना, वही है basically compressibility. Anyways, do the question. Anybody done with the answer? This? Should I give you some options for this one? कर रहा हूँ, 1 मिनट. अच्छा, तुम 3/4L बोल रहे हो? लो, पहला ऑप्शन वही दे दिया. अब बताओ. हाँ बोलो. Option B. Option B is incorrect. Option D is correct. Should I start with the question? I will wait 1 more minute. Huh? How can they be?
No, like regardless if it's an open system or a closed system.
Acha, if there is the medium is same, then yes. Velocity depends on the medium and the temperature as well. I've told. Huh?
Density
Density is
difference.
different, so in this case, it
हाँ तो the velocities obviously are different. Okay then. As I have already told you, compressibility is 1 by bulk modulus. One by bulk modulus, and I will call this to be kappa, and this is B, so kappa equal to 1 by B. Yes. Anyways, if kappa is same, then B is also same. So now let's see what they are asking. A closed organ pipe of this length and other pipe has these densities in between. The medium inside them has these densities. The compressibility are same. That means the bulk modulus is same. Both pipes are vibrating in their first overtone. So what is the first overtone for closed?
3 by 4 is
First overtone is equal to 3v by 4l. But I think the velocity is going to be different and length is also different. What about the open के लिए? It should be VO by LO. And these are given to be same. This is exactly the way in which we have done up until now. है ना? तो यानी 3VC by 4LC is equal to VO by LO. So that means I think they are asking LO. So LO is equal to 4 by 3 LC VO by VC. Bolo. LC is given to be L, na? LC equal to L, but what is the velocity of a longitudinal wave? Under root B by rho. So I think this can be written as 4L by 3 under root B by, what is the density of the medium in open pipe? That's rho 1 ना I think. नहीं rho 2 है. Respectively लिखा है. पहले क्लोज फिर ओपन, तो rho 2 होएगा. फिर उसके बाद क्या होएगा? B by rho 1. ये cancels and then what do you get? 4L by 3 rho 1 by rho 2. Is it okay? I think this was very simple. It's the same technique everywhere. Write this and let me write homework questions for you. And then I will start with the discussion on beats. तो इतना ही लिख लिया क्या? So it's again a very simple question, a repeat question. So hopefully everyone should be able to do it. Huh? Just write this question, then I will start with the next topic, beats.
Sir, what is it after open at
कहाँ पर लिखा है?
second line?
And another pipe P2 open at both ends. Don't try to do it right now, okay? I just write it and then when you're done, then tell me. Take it as a homework. Let's start with the new topic, beats. Okay. If you remember the amplitude variation that we found for a standing wave, it was something like AX to be, I think it was something like 2a0 sine kx, huh? I think it was something like this. And as you can see that the resultant when the two waves interfere, so this is a consequence of interference. Huh? Two waves were moving in opposite directions, they meet at a point, and this is the final result that we get, the amplitude variation. The resultant variation, the resultant amplitude is a function of x, function of space, that's x, yes or no? And this is where we found in the formation of a standing wave. And how is the standing wave formed? When two waves interfere. Then if your interference pattern is giving you an amplitude which is a function of x, then it's called interference in space. Okay, so interference in space gives off, forms standing waves. Okay, we already know all of this and this is the final result that we get. Okay, now let's try to get back to beats. What is beats? So ये तो ऐसा होता है ना, beats में ऐसा होता है, you have a huge amplitude then low, huge amplitude then low, ऐसे ऐसे ना, there's a huge amplitude फिर low फिर उसके बाद. So what you are doing is you are putting your ear at a fixed location and with time the amplitude keeps on increasing, decreasing. Na? So is your amplitude function of x then? No, it's a function of time. Yes or no? As time passes the amplitude keeps on changing. Yes. So again beats is what? Beats is again a consequence of interference, but interference in what now? In time, because your final amplitude is going to be a function of time, and you can already imagine it increases, decreases, increases, decreases. It looks like a sinusoidal, na? Yes. So some kind of function we will get something like this. We will do it next time. I am giving you a bit of intuition what will happen. So your amplitude will be a function of time, a periodic function of time. So anyways, this is interference in time, and due to this what forms beats. So what is beats? It's just again interference, nothing new, but the conditions will be different now. Why? Because if you remember that for formation of a standing wave there were different conditions that you had to follow. Do you remember those conditions? The sources had to follow some conditions. They had to be coherent sources, and the waves must be moving